Hey everyone, welcome back to the Automotive Channel. In today's episode, why do diesel engines deliver more torque than petrol engines? Whether you're a student, a mechanic, or just someone who loves engines, this breakdown will give you the clarity you need. Diesel engines make more torque because, per combustion stroke, they produce higher mean cylinder pressures and often use longer crank leverage, longer stroke, plus they run with more air, turbocharging, and inject fuel differently. Higher pressure times the same piston area, bigger force on the crank, more torque. Key physical ideas. Torque is equal to force times crank radius. Force on the piston is equal to cylinder pressure times piston area. So higher average cylinder pressure, higher torque. Diesels have much higher compression ratios, typically tilde 14, 1 up to 25, 1, hotter denser air at ignition, higher peak and average combustion pressures. Direct, high-pressure fuel injection and diffusion combustion in diesel produce large cylinder pressures across a larger part of the power stroke, more usable force. Turbocharging charge density. Modern diesels force a lot more air into the cylinder, allowing more fuel to be burned per stroke, more energy per stroke, more torque. Mechanical design. Diesels are often long stroke, heavier, and built to handle higher peak pressures. Longer stroke increases crank moment arm torque for the same pressure. The thermodynamics combustion side. Why more pressure? 1. Compression ignition. A diesel compresses only air to a very high pressure and temperature. Fuel is injected into that hot compressed air and auto-ignites. The high compression itself raises the temperature and density of the trapped charge before combustion, so combustion starts from a much higher base pressure temperature than in a gasoline engine. 2. Higher peak and mean pressures. Because of the higher compression and the way fuel is diffused into the hot air, combustion generates higher peak cylinder pressure and, crucially for torque, a higher mean effective pressure during the power stroke. 3. Energy per stroke. More mass of air via turbocharging plus more fuel burned per cycle is equal to more chemical energy converted in one stroke, higher pressures and force on the piston. The mechanical picture, how that becomes torque. Piston force. Where is the average cylinder pressure acting on the piston during the power stroke and is piston area? Torque from one cylinder. Where is the crank radius? Half the stroke. So for a given displacement, increasing the mean pressure or increasing stroke, thus raises torque. Mean effective pressure, MEP. An engine designer's shortcut. Engineers often use brake mean effective pressure, BMEP, as a compact measure of how much useful pressure an engine produces. For a 4-stroke engine, the algebraic result is T is equal to BMEP times VD divided by 4 pi, where is equal to torque, N.M. BMEP is equal to mean effective pressure, Pa, is equal to swept volume, M superscript 3, total displacement. So torque is directly proportional to BMEP and displacement. Diesel engines typically have higher BMEP because of the reasons above, therefore higher torque for the same displacement. Why diesel torque peaks low in the rev band? Diesels produce high BMEP at low RPM for 2 reasons. They rely on high cylinder pressure rather than high revs to make power. Turbocharged diesels are tuned to deliver large mass air at lower engine speeds, and turbocharger sizing boost control favors low-end torque. Result: a big, flat low-end torque curve, perfect for hauling heavy loads and accelerating from low speeds. Practical consequences and trade-offs. High torque, lower peak RPM, lots of pulling power, but less top-end horsepower compared with a similarly sized high-revving gasoline engine. Stronger construction and heavier rotating parts, flywheel, crank. To handle the higher pressures, diesels are heavier. Modern technologies, common rail injection, variable geometry turbo, intercooling, further increase BMEP and low-end torque. Emissions trade-offs. High torque plus rich operation at low RPM affects NOx particulate emissions and requires after-treatment systems. Short summary. Diesels make more torque because each combustion event generates more usable pressure on the piston, higher BMEP, and because engine geometry and turbocharging often increase the mechanical advantage, longer stroke, more air per cycle. Torque scales with mean effective pressure and displacement, so the diesel's higher pressures and charge density directly translate into greater torque, especially at low engine speeds.
Thanks for watching. Stay tuned for more simple and clear automotive explanations, only on the Automotive Channel. If you enjoyed this video, don't forget to hit that like button, drop a comment below, and subscribe to stay updated. Your support helps us bring more helpful content your way. Until next time, drive safe and stay curious.